Gonna do one-way ANOVA in this video using SPSS. I have the diet and weight data here. So there are three diets, 1, 2, 3, and pre-weight and post-weight data after diets and the difference in the diets. So we are gonna do ANOVA to measure weight difference as per three diets. We're gonna go to analyze, compare means, one-way ANOVA. In the dependent list, we'll select our dependent variable, which is weight difference. कितना difference आया है weight में. And in the factor, we'll choose diet, which is our independent variable. And we'll choose some options. Post-hoc, we'll use Tukey's test for the post-hoc test. In options, we'll select descriptives, homogeneity of variance, these robust tests, and means plot. And we'll continue. We'll also select the effect size and we'll click OK. So this is our result. As you can see, this is the descriptive statistics here. So we have three diets, N for H and mean, standard deviation, standard errors, everything here. This is okay. There is no missing value or error. Then we have test of homogeneity. So one of the assumptions of ANOVA test is that the variance of the different groups, we have three groups, diet 1, diet 2, diet 3, should be equal. So if we look at the significance value here, it's 0.3, which is greater than 0.05 and 0.01 significance level. So this is not significant. Okay, so we can reject these scores and we can stay with our null hypothesis that the variances of different groups is same, it's equal, which fulfills the assumptions of ANOVA. So we can move forward now. We come to ANOVA table and we can see that the F value between groups differences. So the means of different groups, three groups. The F statistics for that is 8.157, which is significant at a level of 0.001. So this is great. That means that one of the mean, at least one of the mean of the three groups is different from the others. So post hoc analysis will be significant to do here, right? To identify which group has the significant mean difference separate from others. So this is a significant value. We can move forward now. We go to ANOVA effect sizes and we see eta square here. It is 0.158. So eta square tells us what percentage of the differences, variances is explained by our factor. So here it will be 15.8%, almost 16% variance is explained by the diet. Now we go to the next test, which is robust test. So once our homogeneity of variance assumption is not fulfilled, we use these Welch and Brown-Forsythe test. But because our where assumption is fulfilled, we don't have to do it. But if you're doing it, it's great. It's usually used when our homogeneity variance assumption is not fulfilled. You can see that both are significant, which validates our analysis that F statistic is significant and at least one of the mean is different. You can also see that for both of these statistics is very close to the F statistics, which we had 8.157 earlier, and this is also the same, almost same. For Brown-Forsythe, it is exactly same, and there is a reason for that. Now, in the multiple comparison, we will see what is the difference between the means of different pairs of the groups. So first pair is second and third group. And you can see that it's significant for third group. Again, in the second cluster, it is significant for third group. And then for first group. Now, if we take two groups at one at a time. So diet 1 and diet 2 is not significant. Diet 1 and diet 3 is significant. Similarly, diet 2 and diet 3 is significant. Diet 3 and diet 2 and 1 is significant. So you will notice that diet 3 has a significant mean difference with both group 1 and group 2, which takes us to our next analysis that you will see here that one cluster, which is group 1 and 2, is not significant, and there is a second cluster which has group 3 here, 5.15 mean. This is significant. So we can finally say that diet 3 has significant mean difference and it has substantial effect from other two groups. So it can be said that diet 1 and diet 2 does not affect mean difference much, weight difference much, but diet 3 has significant impact on the weight. Finally, we have the means plot here. So this is the mean of group 1, group 2, and group 3. You can see that the group 3 is significantly different from group 1 and 2. And that's what our findings say. All right, thank you so much for watching. I hope it was helpful. If you have any questions, please comment in the video.